All right, good morning, everybody. No workbook. It's not going to happen. I'll shoot you an email on that. But what I want to do quick is just show a couple of things I'm going to put in here in a hurry to maybe cover some of that content. So, one is this Age of the Ocean Floor map. I'll tell you about that in a sec. Another one that's very helpful is this tectonic plate boundaries. That's a KMZ file, so that's going to open up in Google Earth, which I've already got going right here. What that's going to do when you open it over here, and you can click it on and off, but what it does is it puts these lines on there that will show you all the tectonic plate boundaries. So when you go, and you're going to learn what this is, but when you go to a mid-ocean ridge, you're going to see what's going on with red being where the plates are spreading apart, and green are small transform faults that when you try to do this on a round Earth, you can't get a perfectly straight line. So all these little transform faults offset the stresses with that. But again, you'll learn all that. With the purpose of me showing you this is that it throws those lines on there and can really give you a good view of what type of boundary you're dealing with. And in fact, if you go and click that, it color codes by which type it is. And you can just have that sitting there. You can turn it on and off. It will be really helpful on the quiz. Okay, very helpful on the quiz. So speaking of the quiz, another thing I'm going to do differently this year is if you go to the quiz folder, the quiz is not open yet. That'll be open on Friday. But if you go inside of there, the file that you're going to use on the quiz is there. I usually save that for when you start the quiz. And that, again, you'll open it. I did it ahead of time because I have a slow computer at home. When you open that, what you'll get is all these points, and the quiz will say go to point A, go to point B, blah 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 blah, do this, do that. So yeah, you don't know the questions, but if you want to play with this ahead of time as you're learning them and go and look at the letters and say, okay, maybe this guy's going to ask me about C, maybe this guy's going to ask me about D, maybe he's going to ask me about B, and just start to figure out what's going on in tandem with the one that outlines all the lines. That'll make life pretty easy. Ocean to ocean convergent boundary with a trench. There you go. There's a hint. If H is a question. What else? Now, one of the things that's like a little bit harder. Contents. Sorry, trying to navigate this while looking at a phone screen. I'm going to learn screencasting soon. Let's say two more things. One, because Age of Ocean Floor map. That's the thing that I really like from the workbook that we can't use. So there it is as a poster. Now what the workbook would have done is like superimpose this on Google Earth, so as you fly around you could have done it and they would do some measurements and things. But this shows us with the keys at the bottom where the youngest and oldest bedrock is. So the Atlantic Ocean's a fairly simple situation with it opening up, brand new bedrock being formed along that ridge, and then your oldest bedrock being farthest from the ridge. That's what the blue is. The oldest bedrock tends to be in the ballpark of 200 million years old. But as you start to like learn the different boundaries and how this is all working, this map can be pretty handy to refer to. And let me just mention quick, I think you could probably get all this from reading this little blurb. Students generally do because this isn't in the workbook. But let's mention it. What the heck? We're going to do convergent boundaries, which again, once you watch those videos from Khan Academy that are pretty solid, you'll see how this all works. But what we can do that's kind of neat is looking at the surface of the Earth on Google Earth, we can say if these are the mountains and this is the trench and this is how subduction works, if we look at how far apart those are, we can then do a little bit of trigonometry. And I know that sounds scary, it's been a while, but don't worry about it. It's like one division problem. It's pretty easy and a function, but let your calculator do the work. Where you'll go from A to B, you can measure that distance in Google Earth. How far is it from the trench to that? And if we know this distance, how deep the crust starts to melt, and the numbers in here, that's generalized a little bit, but it's going to get the point across. Then we can figure out how steeply this plate is dipping down. And then the trick is to relate that back to how old the plate is and what happens as the plate gets older. So and these are strong hints for the test. So if you watch this video, look into that stuff. What happens as the plate gets older when it starts to subduct? So the distance from the trench I'm sorry, from the ridge to the trench, or a really young one from the ridge to the trench, or a really long one from the ridge all the way over there to the trench. You can look at those and then see how close those features are. Okay, so the idea, so the idea over here is how far is it from where the plate subducts to where this goes down like into the earth, into my computer screen, essentially melts and then pops back up as a volcano. How far is that in this situation, considering how old the plate is? And then if we go to, because that's got to travel all that way at a couple centimeters a year before it subducts. There's not as much distance on this side over here, from here to here. So what's that distance from the trench to the volcanic mountains? Or up in the Pacific Northwest, Mount St. Helens went off of 40 years ago, I think last month. What's that distance from that ridge where crust is being created to that trench where it's being consumed again by the earth, subducting to those volcanoes? All right, so you'll do all that. You got to do the arctan function, which again, let your calculator do the work. If you haven't done trig in a long time, don't panic. That's it. And I think I put a link for an arctan calculator here. If you use your own calculator, the one thing to watch out for is if all your answers come out right around 0, basically between -1 and 1, you have your calculator set to radians, and we're looking to have it in degrees. So that's like a thing you got to change in a scientific calculator, or just steal that link because that'll make it easy. All right, folks. Good luck. Email with any questions. This one's a 3-dayer. This one's the module 2 is probably the hardest, but with some hints on the quiz there, hopefully we can get some pretty good results. We'll see how it goes. And then after this, we just start hammering through the disasters. But it's like kind of in the framework of tectonics. You can't talk about earthquake, tsunami, volcano without understanding how the Earth is a tectonic planet. So it's an important one, but a hard one at the same time. Email if you have any questions. You got 3 days. Talk to you guys soon.